Okay, this is the second half of Thursday's notes. I told you I would talk about how do you graph logarithms. Well, what we'll want to do first is look at the idea of that inverse. And so this should be on the back of the notes that you already started. And it's an inverse graph. And we looked at inverses the other day by using this plastic reflector. And remember, you put it on your paper and then you kind of look both through it and both at the reflection and at what you see on the other side. So what you want to do is you want to put this on your paper on that line there. And I know you can't really see it anymore, but there's your graph. And you want to look in from this side over here. Look in from the side that has the graph. So look from this area and look over to this side, and over here you should see the reflection of that graph. So I'm going to do that. I do have to move my paper a little bit so I can see it. And if I look in on the left side, I should see a graph starting to form on the right side. So I'm going to take my pencil and trace that graph that I see. Doesn't have to be perfect because I'm just tracing, but notice how that came out. Came out pretty well. So if an exponential graph, which we've done quite a few of now, looks like this, a logarithm graph should look like this. Now the one thing that I didn't quite get right when I was copying it is that this exponential graph never crosses the x-axis. This logarithm graph should never cross the y-axis. So it should actually go down a little steeper than what I drew. If this one has an asymptote at the x-axis, this one will have an asymptote on the y-axis because they're inverses of each other. So if this is my original, y equals 2 to the power x, this is going to be a graph of a function, y equals log base 2 of x, right? Drop and swap. But the inverse, then we swap x and y back, okay? It's an inverse of the exponential function. It undoes it, right? Biggest thing here, when you go to graph these on the calculator does not show this asymptote real well. I don't know why. It's a glitch in the programming on the calculator, but it makes it look like it stops about here. You have to know that it keeps going because it's the inverse of the exponential. It also is going to have an asymptote somewhere, depending on if you've changed the graph or not. So figure out where is that asymptote, where is that line that it never crosses. So let's look at this one. This one's got a little typo. It's got y equals twice. Sorry about that. We just need one of them. All right, but we want log base 3 of x plus 3. When we go into the calculator and go to the y equals, we still use alpha window and choose number 5 for log base. We'll put log base 3 of x. Now notice there's no parentheses here, but there's parentheses here. If that's the case, you only put the very first piece in parentheses. So we'll put the x in parentheses, but not the plus 3. So we'll arrow out of those parentheses and put plus 3 after it. Very important. Then when we go to our graph, oops, my window's off. I'm going to hit zoom 6 to get a standard window. Notice how it seems to stop right here. But you and I know that it's the inverse of an exponential, so it needs to have an asymptote. If we need to know where the asymptote is, go to the table and figure out where's the first place it has an error. Its error is at 0. That's where its asymptote is. It'll never cross the line 0. We do have a point at 1, 3, 3, 4. Let's get those on there. And 9, 5. So over 1 up 3, over 3 up 4. And the last one was 9, 5. Right about here. And then we'll sketch it in, making sure we show the asymptote at 0, which means it never crosses the y-axis. So that plus 3, just like we did with our other transformations, just move this graph that we had over here up a little bit. All right, let's go ahead for note's sake anyway. This is our asymptote. All right. Now, how do you think this one will differ? This one moved up 3. What do you think will happen here? All right, I hope you have a prediction. We're going to go ahead and graph it and see. So I'm going to go to the y equals, and this time x plus 3 is in parentheses instead of the plus 3 being out of parentheses. So inside the parentheses, I'm going to put the plus 3. Let's get that out of the glare where you can see it. And we're going to hit graph. Notice that this time it moved to the left 3 spaces, just like parabolas and all the other transformations we've done. So be careful with that. But the x plus 3 moved this one to the left. If we need to know where our asymptote is, go to the table. And the first place where we see error is at -3. Our asymptote is at -3. Remember h and k? This is just our k value, h value, excuse me. -3 though, remember it changes sign in the parentheses. So our asymptote is at -3. We've got a point at -2, 0. Another whole number point at 0, 1. And a final whole number point at 6, 2. And then don't forget, your asymptote is at -3, so never let it cross or touch this line at -3. Don't cross that line, okay? So we turn it down, we make it go down forever, even though the calculator didn't show that, and then we follow these that way. That's how you graph logarithm graphs. I'm going to let you guys work on that on the worksheet now. Good luck, and I'll see you soon. Don't forget to do your study island today.